A common kind of problem is what is known as an impossible integral. And something like this that's impossible is almost always found on the calculator portion of the AP exam, whether it be free response or multiple choice. So notice the structure of the question, or part of this. We've got f of x, big F of x, and it's the antiderivative of x over x cubed plus 1. So what that means is f of x is what you would get if you could integrate x over x cubed plus 1 dx. Now in the calculator section, a lot of times you'll have integrals where they're forcing you to use your calculator to integrate. Now notice the question. If f of 0 equals 2, find f of 3. And so one thing that people think about in this case is, alright, well I'm going to try and integrate, and they get bogged down trying to integrate, particularly on the calculator section. But the point of the problem is to test just your recognition of the relationship between these things. That if you were to look at f of 3 minus f of 0, that would be what you got if you were to integrate this from 0 to 3 from x over x cubed plus 1 dx. And the fact that it's impossible to integrate is part of the issue. Is just it's the calculator portion, right? If it's the non-calculator portion, you've got to be able to integrate it by hand. You could still have this kind of problem, but we're talking impossible. We're really alluding to the calculator section. F of 0 equals 2, so I'll make that substitution. And if I add 2 to both sides, I've got an expression for what I'm looking for, that f of 3 will equal 2 plus my integral from 0 to 3 from x over x cubed plus 1 dx. And at this point it's just a calculator exercise. So recall that to integrate this, I'm going to put my function in y1 in the graph screen, so I'll have x over x cubed plus 1. And the notation is function integrate, which is math 9. And I'll use y1, which is found under vars, then choose yvars, then choose function, then choose y1. I want to integrate this with respect to x, so comma x. I want to integrate it from 0, so comma 0, to 3, comma 3, and hit enter. And really it's just going to be 2 plus this amount. And once you enter that in your calculator, you end up with f of 3 is about 2.879. And we've answered the question. Let's look at 2 more examples. So again, f of x is the antiderivative. So f of x is the integral. Just skip the problem. So here, f of x is the antiderivative, or f of x is the integral of the square root of 4x squared plus 5 dx. And we're told that f of 1 equals 3, and we'd like to find f of 5. So immediately we need to think, alright, well f of 5 minus f of 1 will equal the integral from 1 to 5 of the square root of 4x squared plus 5. And again, on the calculator section, don't even bother integrating. Use your calculator. In the non-calculator section, it has to be something you can integrate. We know that f of 1 equals 3, so adding 3 to both sides, we know that f of 5 equals 3 plus the integral from 1 to 5 of the square root of 4x squared plus 5 dx. And again, in y1, I'll put the square root of 4x squared plus 5, and then it's math 9 to get function integrate on my calculator. And with parentheses, I'll have y1. Again, y1 comes from vars, yvars, function, y1, comma x, because I'm integrating with respect to x, comma 1, comma 5, because those are my limits of integration. And to that quantity, I'm just going to add 3. And when I enter this into my calculator and hit enter, I get that f of 5 is about 28.866. Let's consider one more problem. Let f of x be the antiderivative of e to the x squared dx. We're told what f of negative 1 is. We'd like to find f of negative 2. So, I know that f of negative 1 minus f of negative 2 equals the integral from negative 2 to negative 1 of e to the x squared dx. I know that f of negative 1 equals 2, so what I'm going to do is add f of negative 2 to both sides and subtract my integral from both sides. And now I've got everything set up to solve for f of negative 2. Again, I'm going to put y1 into, set y1 equal to e to the x squared power. And then I'll use math 9 to get function integrate. And my notation on the TI-83 is y1, which comes from vars, y-vars, function, choose y1, comma x, because that's what I'm integrating to. And my integral is from negative 2 to negative 1. And my notation will be 2 minus this quantity. When I calculate this, I end up with f of negative 2 equals about negative 12.990. So I've solved the problem that involves some impossible integrals, which are pretty standard on the calculator section. Impossible integrals. And these kinds of problem solving for something are fairly standard, where you just need to recognize the fundamental theorem of calculus.